Alright, section 3 is on congruent triangles. This is where we start to get to where the proofs of geometry comes into play. The chapter 2, that was just child's play proofs. These are the difficult ones where you have to prove two objects are congruent. So the objective is to use properties of congruent triangles and to prove triangles congruent by using the definition of congruence. Alright, there's your vocabulary. Can't wait. Alright, so geometric figures are congruent if they are the same size and shape. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. So real quick, these are not the same corresponding angles as this. This is not what it's talking about by corresponding angles. Yes, these are corresponding if they're parallel, but what it's going to mean by this is if this is 45 and this is 45, these angles correspond to each other. They pair up, basically. So we'll get to that. So geometric figures are congruent if they are the same size and shape. First buzzword is corresponding angles and corresponding sides. Or corresponding angles are the first buzzword. That's it. And corresponding sides are in the same position in polygons with an equal number of sides. Two polygons are congruent polygons if and only if their corresponding sides are congruent. This is also called a biconditional. Yay, biconditionals. Two polygons are congruent polygons if and only if their corresponding sides are congruent. Thus, triangles that are the same size and shape are congruent. So let's prove some of that. Alright, so properties of congruent polygons. For a triangle, all three sides or all three angles have to have a pair. So notice how the red angles are paired up, the blue angles are paired up, the green angles are paired up. And we've got tick marks for all of these. Tick, 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 all those. So the corresponding angles, we have three sets of angles paired up. This is what it means by to be corresponding angles in terms of polygons. So the A matches up, the B and E matches up, the C and F matches up, the sides match up, the sides match up. These are all the corresponding. Alright, so same thing with polygons. A square is going to be the same story, except we're mainly going to focus on triangles. We may have an example of a square, but really we're going to deal with triangles on this chapter. Alright, so this is saying two vertices that are the endpoints of a side are called consecutive vertices. So let me redraw this rectangle they're talking about from the last example. This was a P here, this was a Q, this was an S, and this was an R. So to be consecutive vertices, so P and Q, they're side by side. That's all it's really saying. So P and Q are consecutive vertices, P and S are consecutive. I can get from one to the other by following one line. I cannot get to S to R without tracing over, or S to Q, sorry. I cannot get from S to Q without going to R or P. So S and Q are not consecutive, P and R are not consecutive. So I don't think this is going to be too much of a problem for us. P is consecutive to S, S to R. It's just connect the dots here. Alright, to name a polygon, you're going to write the vertices in consecutive order. So basically, we're going to play connect the dots. So on that last one, we had the rectangle P, Q, R, S. And this is important because a lot of people get this wrong. To name this polygon, I have to start at a point and I basically connect the dots until I get back to it. So I can say P, Q, R, S. I went in order. I started at one place and I stopped at my last spot. Or I can start at Q and go Q, R, S, P. Or I can start down here at S and go the other way. S, R, Q, P. I cannot go, watch my pen when I trace this out. I cannot go P to R to Q or to S. Yeah. I cannot go P to R to Q to S. So this is not the polygon. I have to go in order. Alright, when you write a statement such as triangle ABC is congruent to triangle DEF, you are also stating which parts are congruent. So if I see this on your paper, I'm assuming you're going to say A matches up with D, B matches up with E, and C matches up with F. So ABC matches up with DEF. So if polygon LMNP is congruent to polygon EFGH, identify all the pairs of corresponding congruent parts. So I'm going to quickly make a list of corresponding angles and corresponding sides. So the angles, I'm going to look at the first one. This is angle L, that's angle E. So angle L is congruent to angle E. I just picked the first one. Angle M is going to be congruent to angle F. Angle N is going to be congruent to the third one, angle G. It's just this simple. Angle P is congruent to angle H. Corresponding side. So this is going to be some polygon, and this is going to be a polygon. Using 2 points, I can name a side. So the same way that LM is a side, LM is the first two written on the first one. So I'm going to say it's congruent to the first two on the second one. Then we have MN, middle two congruent to the middle two, last two congruent to the last two. And then, since there are 4 sides, this L and P are a side too. So I have to go back to the last one, first one is congruent to the last one, first one. So again, all I've done is I've paired up my angles, L to E, M to F, N to G, P to H. 1, 2, 3, 4, 1, 2, 3, 4. My sides to sides, side, 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 side. Alright, there's only 2 more examples, and this is where we get into the proof of it. Or this isn't a proof, this is just finding something. So this isn't too bad yet. Just wait, it gets worse. Alright, so I'm going to find the value of x, and they know that this is congruent. That's what that box means. ABC is congruent to DEF. So first of all, let me find the x information. X is right here. So BA has my x value. So I'm going to first look at BA. First I want to know, what is BA congruent to? Well, if I look at my list up here, it says BA, this is the first 2 listed. So it's going to be congruent to the first 2 listed over here. So it's going to be congruent to DE. Now I go over to the second triangle and figure out what my DE information is. Well, it's right here. It's 6. So all I'm going to do is set 2x minus 2 equal to 6 and solve. So that one wasn't too bad. The next one is our last example, and we're going to get into the proof of it. Alright, so excuse my writing. The stuff over here got messed up when I tried to put it into this program, so it didn't work. We are given that angle YWX and angle YWZ are right angles. YW bisects XYZ. W is the midpoint of XZ, and XY is congruent to YZ. So I'm going to draw this picture a little bit bigger so we can do stuff with it. Alright. So we've got X, Y, Z, W. So given my information, I'm going to go in and mark up my diagram so I know kind of what's going on. So first it said YWX and YWZ are right angles, so I'm going to put these right angle boxes in there. Then it says YW bisects XYZ. So this line bisects this angle. So I know this angle gets cut in half equally. So this angle is equal to this angle. Alright. Now I know my third angle theorem tells me, since I've got 2 angles matched up with an angle on each side, so this has a 90-degree angle, this has a 90-degree angle. This is congruent, this is congruent. So since these 2 match up, the last 2 have to match up. Alright, and it tells me next, W is the midpoint of XZ. W is the midpoint of this line right here. So since W is the midpoint, this line is going to be congruent to this line. And then lastly, they tell me XY is congruent to YZ. So then that's going to be right here and right there. So I'm almost there. I've got 3 angles and I've got 2 sides. To prove triangles congruent, I need to prove that all the sides are congruent to each other and all the angles are congruent to each other. But there is one last side that they don't tell us, but we do know what it is. This side right here is a side to both triangles. This YW, if I broke this triangle into 2 different ones, it would be W here, W there, y, y. This is x, this is z. So if I broke these two, if I cut down the middle and I separated these two, that line would be duplicated on both of them. So we're going to say YW is congruent to itself. So what proof are we going to use when we say YW equals YW? That's going to be our reflexive that we finally have a purpose for. Alright, so now let's do a 2-column proof of this. Make this a little smaller so I can write my proof. Alright, so I got all this stuff, and it's the given information. I'm not going to write it all out because I don't have the room for it. I suggest you do. Alright, so I've got the angles. I've got basically the only thing I know here is that the right angles are there, and that's it. And these ones are congruent. Before I can prove they're congruent, I have to prove in this 2-column proof that everything's congruent. So first I'm going to start with the easy one. I'm going to say YW equals YW, and that's reflexive. Next I'm going to go XW is congruent or equal to WZ. That's the definition of midpoint. Because they told us W is the midpoint, I know these two are congruent. So the fact that these are equal is the definition of midpoint. Alright, and so this is our bottom side, this is the side going to the middle. The sides, these diagonals, this was given to us, so that's already mentioned. Alright, now I know angle, I already know that angle XWY and ZWY are congruent because that was given to me that they're both right angles. Now I need to say, now I need to say that angle XYW is congruent to angle WYZ. So let's find that angle. Here's XYW and here's WYZ. Why are these congruent? Well, the bisector told us they were, so that's just, again, definition of bisector. Alright. So now I've got the bisector going on. I've got my one angle here. I've got one angle. These angles have been proven. These angles have been proven. Or no, these angles, sorry. These two angles have been proven. So now the fact that angle X is congruent to angle Z is just the third angle theorem. Alright, and now I can finally say triangle XYW is congruent to ZYW. And that's the definition of congruent triangles. Alright, we will be doing several examples in class, so just wait. It'll be so much fun.